I'd like to take a slight digression and to note that today where I live is called Patriots Day. 249 years ago, the American Revolutionary War began just down the street from my house. And that set off the events that eventually led to the beginning of the United States of America. I should also note, and I'm doing this a little bit for one of our future speakers, that today is also Boston Marathon Day, where we had the 128th running, or the 2 to the 7th running of all the world's elite runners in this particular marathon, won in the male category by someone from Ethiopia. So let me now turn to the gist of my speech, and I want to talk a little bit about the 6G vision. I'm going to start a bit by looking at what the ITU has done. And for those of you who know, beginning with 3G, the ITU has sort of set the stage, the vision, a bit of the framework for the various Gs. And in November, the ITU approved recommendation M2160, which is a framework for 6G, or what they really call in ITU parlance, IMT 2030. The ITU doesn't use the G terminology at all. This builds upon really 5G. And if you look at the left diagram on the left side, you sort of see at the center, the triangle which made up 5G, enhanced mobile broadband, massive machine type communications, ultra reliable low latency communications. That has now been sort of redefined, those terms, and expanded and changed slightly. But to that, we've added 3 new basic things. Integrated sensing and communications, really using the technology to be able to sense the environment around us and then to somehow aggregate and in some sense use AI then to help identify and understand what's happening around. Clearly AI in communications. Now I look at AI in communications in 2 ways. One is communications talking between entities which are dealing with AI. And the second is AI inside the communications network to enhance the performance of the network. We'll talk a little bit more about that later. And then, of course, ubiquitous connectivity. And to me, connectivity is one of the really key things. Around it are the several big themes. I think the most important these days, from what we can do technologically, is sustainability, and then security and resilience. Now, soon after the first release of 3GPP 5G, a number of researchers started to turn, primarily in the academic arena, towards researching 6G. And also we started to see some of the industry organizations spring up around the world that were addressing 6G. In most places, these were basically similar structured organizations to those which we saw for 5G, such as in China, IMT 2030 PG, previously the IMT 2020 PG. However, there are 2 new groups really out there. The first is Abroad 6G in India, and the second is a NextG Alliance in North America. And since I'm from the United States, I really would like to spend a couple of minutes talking about some of the North American activities on 6G. First, let me talk about the NextG Alliance. NextG Alliance is an industry organization. In fact, it's industry-led. In fact, when it was formed, there was no government involvement at all by the rules of the organization. They were later changed to allow government to participate in the working groups, but not in any of the decision-making or any of the more higher-level groups, i.e. more the plenary type parts of the organization. I should note that most all the participants are coming from the United States and Canada. The main focus of this group has been to create white papers. So far, they've published 24 of them. You can see those on the right side of it. By the way, I understand 3GPP is going to create a new logo, which may look slightly different, but hey, we'll see where that goes. And the second thing that is done is to create a bunch of lectures on topics related to 5G from academics working in the field. Mostly those presentations have been on things such as sort of technologies, visions, technologies, actually some economics ones, green aspects and such. The white papers have been published carry a wide range of topics in them, everything from various roadmaps to talking about the economics, greening, and things like that. By the way, you can get all of those white papers on the website. I should note that the Next G Alliance, by the rules of the organization, has no intent to develop any standards. That is expected to be done by 3GPP. There. I should note that I'm not going to talk in the rest of my presentation about any of the plans by 3GPP. I think I'm followed by a number of the 3GPP leaders, which I'm sure will be talking about what 3GPP is so far planning to do. Nor am I going to talk really about any of the 5G releases, which are so important and are continuing there. So let me talk a little bit about research funding. In the United States, the National Science Foundation, better known as the NSF, funds academic research. It doesn't fund any industry research. Actually, to enhance the research a bit in the telecommunications area, a number of companies got together and put in a bit of seed money, which then the National Science Foundation multiplied many ways to create a bit more research. By the way, I should also note that the National Science Foundation does not have a 6G policy or a 6G program. Yes, some projects or some grants may have the words 6G in them, but these are typically small amounts of money. And this is because the National Science Foundation looks at, hey, we're doing research not to any one particular system, but for all potential communication systems. And the results can be used by any of them, whether they're Wi-Fi 3G or something else. So I'd like to turn on my next slide to what I consider some of the really big challenges and issues that we need to deal with for 6G. And the first one that I'd like to highlight is really coverage. And I know say, yeah, coverage. Yeah, we can add more cell sites to enhance coverage. But what's really happened? As our demand for data has gone up, and David was talking a lot about, hey, we're going to go through a lot of data. The question is how do we get that data to the user or from the user to the system? Okay, and what's happened? Hey, as the data rates have increased, hey, we have power limitations both in the UE, the device, and the infrastructure in the cell sites. Furthermore, as the data rates have gone up, we needed more bandwidth, which has driven us to higher frequencies. That link budgets tend to be worse as a result of, hey, I can't build antennas with the same area, and I have this issue of, hey, materials typically have greater loss at these higher frequencies. You can say, oh, we can add more cell sites. Yes, we can, but that gets into the economics of the system and what is the operator willing to pay to provide their systems here. So one of the challenges is how do we get the coverage that we need? Yes, people have looked at not only small cells, RISs or reconfigurable intelligent surfaces, repeaters, and other technologies. But we have to think about fundamentally what it is that we can do to enhance the coverage of our systems. I mean, but I want to look at the cost of deploying a new cell, whether or RIS or repeater or whatever. We have to deal with potentially siting, costs of maybe a room to house the equipment, power, and also tuning of the system. So one of the big areas where I think we can do a lot on is using much of the AI technology to do automated tuning. We don't have to do drive testing or field verifications of that. Potentially, we can use data collection from devices, federated learning type techniques, digital twins in addition. And a third thing that I want to talk about is a little bit sustainability. And this gets into, hey, what's the cost of operation? Right now, our radio networks, mostly driven by what's at the cell site today, takes almost 3/4 of the power consumption of the operator's network. How can we reduce that? Some of that's going to come from better implementations, Some may be able to be dealt with by the standard, such as maybe smooth operation between the various bands, i.e. shutting down bands very, very smoothly so that there's no impact to the user, no impact to the traffic, and such, as the load goes up and down in the particular network. And then other things that we may be able to do that really just minimize some of the other power consumptions at various times in the usage of the network. I'll leave it to the technology folks debating in 3GPP to come up with this. And of course, we have to support a lot of growth in traffic. Now, I want to turn ourselves briefly here to spectrum. Traditionally, spectrum has been a big driver for each of the Gs and has actually helped pull deployments of the various Gs and to actually pull technology forward. For example, in 5G, we had the millimeter wave spectrum allocated. Lots of spectrum there has really spurred the development of a lot of technology as it relates to millimeter wave. It's still in its infancy relatively. Difficulties of deploying at these higher bands to get coverage, even though we really think about those bands as being sort of incremental in coverage, and really providing spot coverage or filling in holes and trying to offload the lower frequency bands in terms of overall. So let me turn back to what's really been happening. For 5G, we had a good amount of spectrum being allocated. In WRC-19, we had spectrum typically allocated around 3.5 gigahertz. Actually, in WRC-23, we've added some more spectrum in that frequency range, which really just was codifying what's already been allocated in certain parts of the world. We have 600 megahertz spectrum, not a lot. Okay, now let's look at what might be doable for 6G, or some people even think about 5G, but I think it's really going to be 6G. One of the big areas of spectrum which has been hotly debated as part of WRC leading up to it and will be continued debated is what we call the upper 6 gigahertz spectrum. That's the 6.425 to 7.025 gigahertz spectrum. In Region 1, and in certain countries in Region 2 and Region 3, and that's by footnote, which means coordination, it has been allocated to IMT, or cellular usages. However, other countries of the world have allocated it to unlicensed operation, aka Wi-Fi type of usages there. Now, what's interesting about this is certainly in Europe, and particularly in the CEP processes, there'll probably be a lot of studying of whether we can have coexistence on the same band between Wi-Fi and IMT. And the thoughts are, hey, if we can do some coordination between them, and since Wi-Fi is primarily indoors, a lot of cellular is outdoors, maybe there is a way we can coordinate these, giving priority to cellular. We'll see how this comes out. Stay tuned on that. A second area of spectrum uses that's being looked at is the stuff above that. Typically the stuff in 7125 to 84 gigahertz. And this is an interesting band, and it will be a difficult one to basically have the ITU identify for 6G. And the primary reason is there's a lot already in there. For example, there's X-band satellites used by governments and militaries around the world. So it'll be interesting. But what I'm saying is we're moving into the world where we're going to have to be looking at sharing, and sharing between systems and different types of systems. And there's going to be a lot of reluctance by the existing, I'll call it spectrum owners, to allow sharing, but we have to really think about it in this sense. And the reason is there's not a lot of good spectrum available. Now, I just want to highlight that by just saying, hey, the next things there are, parts of Region 2 allocated, or I should say identified, to use the IT term correctly, 10 to 10.5 gigahertz. However, 500 megahertz is nice, but hey, the transmit power allowed is very limited. So it's maybe only good for small cells. Not so good. And then there's looking at 14.8 to 15.3.5 gigahertz, higher than people would like in terms of frequency. So again, sharing and maybe other ways we can more efficiently, even the cellular thing, as David was previously mentioned, much more effectively and efficiently use our spectrum, and particularly when certain parts are idle and are potentially needed by others. More will occur in the future on this. Now let's go back to sort of the experiences all. And David talked a bit of experiences. We're going to talk about a whole bunch more. A lot of things relative to, hey, verticals. Now, we had hoped to basically move a lot more forward in verticals with 5G. I'll be straightforward on that. I think for many people, it's not moved forward quite as fast as they'd like. I think a few that are moving, we've moved forward. China's done a really good job on trying to get CV2X deployed. I think the US is moving forward on that now after a few little things going on there using on CV2X. But many of the other verticals have been a bit slower to pick up. And we also have to realize that that takes a while for many of these verticals to really understand the communications and the value to them, and then they need to adapt their industry. Also, their requirements and their thinking is a bit different. They tend to want to have a system, often test it and verify it, and then have it operate for many, many, many years. So this also says something that what we need to do on our systems, such as the networks being supplied by the carrier, we need to guarantee them basically a system that will be available 20 years later or something like that, and that they will still be able to use it. XR is actually moving forward a lot, albeit maybe a little bit slower than one had expected. I think Apple, with its Vision Pro, whether you like them particularly or not, has now come down and will help move the industry forward. Apple with their glasses, or I should say really their mixed reality goggles, really joining probably the dozens of other different glasses and goggles that are out there today. And we can talk about many of these other use cases, but I will move forward and talk about one thing here. And I'm going to talk about AI in two cases. The first case, which I'm really going to talk about here, is how do we use AI more in the application environments. Okay, and this is something that's coming very, very, very rapid. You know, Qualcomm in our chips that go into the latest Snapdragon Gen 3 and then will be Gen 4 phones and such, have sophisticated AI capabilities. So we're able to move AI to the edge. So we thought about AI processing primarily in the cloud. But now if we move AI to the edge, to the device, we can do a lot of things directly on the device. This cuts down on the communications traffic, okay, which more importantly also will help cut down on the delay. It also gives a bit better privacy and security to the user. So we're visualizing that, hey, our phone could be a true digital assistant. We're visualizing that all sorts of things like voice-to-text recognition, speech translation between languages, all can be done directly in the phone, dynamically, and not necessarily with network connectivity. And then, of course, things which can't be done well on the phone can move the network. Lots of questions here of what goes where or what fits where, and I'm expecting a tremendous amount of innovation in this area where people will be starting to really develop a lot of apps on various devices there. Of course, AI can be used all sorts of other areas in the system and the network, but I just wanted to sort of highlight what we're starting to get to on the device. Now, I want to highlight some other trends that are going on, and one of the trends that are going on is really, quote, the open system. And David was talking about that, and, you know, of course, he was quite heavily involved with AT&T and NFV and all of that. And that's something that really sort of occurred, even started to really occur before the 5G era significantly. But moving to virtualization of these network functions using common hardware, particularly in the cloud, where it's possible. One of the other big areas is really the open front haul, and I should say the work that's really been around the Open RAN Alliance. And by the way, the Open RAN Alliance or ORAN Alliance has really done much more than just the open front haul. It's done a lot of other things like the RIC, near real-time RIC, etc., and other various interfaces. But I want to focus on the front haul because to me that is really the real key here. And I think it's become even more key because a number of major vendors of infrastructure have sort of made some announcements about actually supporting open front haul. And why I think this is powerful is it allows us to perhaps with for operators to really mix equipment from different vendors. And I'm primarily saying that one vendor may be very good at building macro cells, the equipment that goes on the cell tower for macro cells very well. Another vendor may do very well at building very small cells. This maybe allows us to really intermix them well in a way that we haven't really been able to do. And that to me may help somewhat with the economics for the operator and also help with this coverage thing that I was really talking about a bit earlier. Stay tuned on this. One of the issues with ORAN in 5G was really the open front haul specs were not available sort of at the get-go or at the beginning of when really people started to develop infrastructure and all that. I'm hoping that for 6G, the specifications will be in place and then vendors can start by developing to that particular architecture and that particular functional split between the RU and the DU. I want to talk about two other things here. One of them is something that we learned really from the internet, which is really providing IP-based connectivity for everything and really putting all the services over the user plane versus running any of them through the control plane. And why is this? Is that you don't want to touch the core of the network really to make any change. You want to have a server out there and you want to really impact maybe the server and the client in the device, and that's only it in that. And by the way, it doesn't matter whether the server is run by the operator that's providing the service or really run by an over-the-top provider. And then finally, I'd like to mention open source. There's been a general movement to that. I mean, we see this, in the cloud by Kubernetes. There's now Nefio open source project really taking Kubernetes more towards some of the real-time aspects of it. I think a relatively successful project has been OAI or Open Air Interface software, which has really provided a reference design for the infrastructure for 5G and such. One of the other directions we'll see is, I think, integration with other communication systems. I think NTN has really brought us forth in terms of what we're going to see in terms of satellite things, and it really opened up people's eyes to what we could do. In fact, if you remember, NTN was originally developed to provide communications to maybe a special terminal or device such as an IoT device. But then when people started asking questions, well, what can I do to the handset? And now all of a sudden, it's like, what can we do to the handset to enhance coverage? Now today, we're sort of limited to a bit what we can do at relatively low data rates, maybe a little bit of messaging, emergency messaging and such, which is what Apple is doing in their iPhone. I'm hoping we're going to be able to get up with better satellite systems and all that by going into maybe some voice and actually useful for at least email and some other things there. Better integration with Wi-Fi. Okay, I think that's something that is coming where we make the Wi-Fi cellular experience really seamless there. I think we have to admit in many parts of the world, Wi-Fi is really a major part of the communication system, and today it just takes too much effort to really move between the two networks and to set up things. Private networks is something that we really didn't talk too much about before sort of the 5G time frame. I see a continual expansion of this. And this is what, regardless of whether the private network is run by the operator or it's on separate spectrum, that's basically been allocated to the user of the private network, i.e. what we call locally licensed spectrum. But there is a tremendous opportunity as well as potential demand to run these networks for various manufacturing campuses, users of all types in this. I see good integration of optical networks. Okay, and I think and bringing in fact, David was just mentioning that, of the speeds that AT&T is deploying its optical networks. NTT in Japan has this I-1 project, which is really trying to integrate through optical switching and everything like that. And of course, I don't think it's going to affect maybe our air interfaces too much on 6G, but we should take a look and keep that type of mindset in our thinking in doing that. And I threw at the end drones, or I should say airborne mobility of various types here. This is something that I think will be coming. And certainly, I think there's a long way to go still in the cellular arena. It's slow, a lot due to regulatory issues, liability issues, and such. But I think we're going to be able to use our cellular systems also to control this, and to be able to control potentially the masses of drones that will be appearing in the future. I'd like to end just with a couple slides talking a little bit about what we're doing today. And this is really, in my opinion, the beginning of AI in the air interface. We're able to use multi-antenna management to really improve the user experience. This is particularly in millimeter wave operation. We've been able to use it basically to improve the accuracy of location. Okay, in some sense, any system which really is nonlinear and has nonlinear components or complexity to it is potentially open to enhancement with AI. However, we do need to pay attention and to note that AI can take a lot more power than traditional means. Therefore, we have to look at it and really understand the problems appropriately as we apply AI. I'm going to skip this, but we've done a lot of work on millimeter wave beam management. This is really an important thing. By just moving 10 centimeters and things like that, you can be swapping beams. You can swap them very rapidly because the propagation environment from millimeter wave is exceedingly rich. Okay, and that's because the small wavelength of millimeter waves means it can reflect almost off of anything out there. I'm going to leave that. If you want to learn a bit more about some of the work that we've been doing, please go visit some of our websites, which will connect you to some of the videos that are out there. Thank you all very much, and good luck on the rest of the event. I'll see you in a panel in a couple of hours.